Good afternoon, one and all. I am Nikhil. I am studying Diploma in Tool Engineering and Digital Manufacturing, 5th semester in NTTF Gannavaram Training Center. Today, I am here to present my short talk. And my topic is hot chamber process. Before going to know about hot chamber molding process, we should know the important thing is we should know about the die casting. The hot chamber molding process is one of the type in die casting process. In the die casting, there are several types. Today, we are going to know about the hot chamber die casting process. In this process, we commonly use of the production of small to medium sized components. The components which are having small sizes and medium sizes are only allowable for this hot chamber molding process. And the components which are having intricate details. What is the meaning of intricate? The intricate means the component which is having an critical shapes or critical edges. Those components are very easy and suitable for this hot chamber molding process. And also, particularly the materials which are having low melting point are only suitable for this hot chamber process. Without having any low melting point, we cannot use this hot chamber molding process. What are the low melting points materials? Such as zinc, tin, and lead. Today we are going to know about the working process of this hot chamber molding process. Before going to know about the working process, let us see some keywords. Melting, injection, mold filling, cooling and solidification, ejection. Let us move step by step and let us know brief about these keywords. At first, let us see the melting. In the hot chamber die casting machine, a crucible is typically located within the machine itself. What is crucible? For better understanding, let us move to the cold chamber process. In the cold chamber process, the injection, the screw type injection is similar to this crucible. In that, the crucible maintains the molten flow which maintains the liquid into a liquid state by maintaining such a certain temperature. This crucible is holding an molten material like zinc, tin, or lead, or any low melting point alloys. In this picture, we can observe the crucible. So this is how the crucible looks. This crucible is mainly used in casting products. Let's move to the second one, injection. Normally, in cold working process, the injection which is used is screw type injection. But in this, especially we are going to use about the gooseneck or piston forced to molten the metal into the short chamber. Here, the short chamber is nothing but mold, which is cavity and core. This is connected to an die casting mold. The short chamber acts as an reservoir, ensuring a constant supply of molten material. Let us know about briefly. That means it acts as a reservoir means in the crucible there will be an molten material and the gooseneck or the piston makes the material flow into the mold with the help of piston. The force will be acting on the piston. So that is why this is also called as an reservoir. In this picture, we can observe the fixed half and moving off component and also ejector pins and also the gooseneck. So that is called an gooseneck because it looks as an gooseneck, and that is called as an piston, which is used to make the molten material flow to the chamber. This piston is having a major disadvantage, like the piston is used for filling the material into the mold cavities. In that process, there is 100% chances to wear out the piston. Now let us move to the next step. Mold filling. The high pressure injection system forces to the mold melt into the mold cavity, which is made of two hardened steel dies that are precisely maintained to create the desired parts and shape. Here, the mold filling is similar to a cold chamber working process. There will be no difference between the cold working process and also hot working process in this mold filling. And the mold is rapidly solidified within the mold. The runner system is a network of channels that distribute the molten metals to various parts of the mold. Here we have to identify one major thing. In the cold working process, if there is any critical state, the material is not going to reach the edges of the components. Like the networks of the channel to distribute the molten material is not possible. But in the hot chamber working process, the material is very easy to flow to the various parts of the mold. Now let us see about the cooling and solidification. This is also similar to the cold working process. Once the molten material is injected into the mold, it quickly cools the solidifies, taking on the shape of the mold cavity. It is as usual to the cold working process, but the cooling process is usually assigned by the water cooling channels within the mold. And finally, let us see about the ejection. After the part has fully solidified, the die opens and the part is ejected from the mold. Here, the movable platen or the cavity will move backside and the ejector rod maintains at the same position. By that, the component is going to ejected. The excess melt left in the short chamber is then replenished for the next cycle. That means this material is recyclable. So that is why if any excess material is left in the hot chamber, will also get the manufactured in the second cycle. Now let us see a small video of the function of this hot chamber molding process. But before watching this video, let me tell you one thing. This was not a gooseneck mechanism, but we can see here the mechanism of crucible and also the mechanism of the plunger or piston. Let's watch a video.
In a die casting sleeve, mold closes, following which ladle pours the molten alloy into the shot sleeve. Plunger tip starts pushing the molten alloy into the cavity of the mold. The molten alloy fills into the cavity through gates and runners. The molten metal cools down to achieve the state of solidification. After solidification, the mold opens up, the casted part is ejected and taken out. In this cycle, we can see common defects in.
So we have seen in video, right? What we have observed in this video? In this video, we have observed crucible, which is having a molten material into that, and it has poured into an hopper type material, and also the plunger is acting to push the material into the chamber. So this is how the hot chamber molding process works. And finally, let us see some advantages and also disadvantages. First, let us see advantages. The advantages are high precision. What is the term of high precision? The high precision in the terms where we need and tolerance, accuracy, and precision are able to maintain in this hot chamber molding process. And second one, process of is fast. That means in the name itself, we can observe hot chamber process. That means the molten material will be in an hot condition, means that will be in a liquid form. So that is why it is easy to fill the material and to make a mass production. And the second one is high dimensional stability. In the hot chamber process, we use the material of which is having low melting point like zinc, tin, or lead. These materials are having low melting point, so that is why the material is very easy to flow to a different edges of the components, even though the components are critical angles and critical edges too. And fourth one, surface finish. The surface finish will be good. And high production efficiency and design flexibility. The design flexibility in the terms, the designer can make any complex profiles of an plastic component, because due to the flexibility of the material is high. And last one, recycling. Now let us see the disadvantages. Limited material. That means only the materials which are having low melting point like zinc, lead, and tin, or any zinc alloy materials are only suitable for this patient. Not over like copper, brass, aluminum. These type of materials are not suitable for this hot chamber molding process. And second one is limited temperature range. The temperature range must be constant according to an low melting point, according to the material, for example, zinc. So that is why this is a disadvantage. And the third one is part size limitation. In the beginning of this presentation, we have observed that only the small and medium sized components were allowable. So we cannot produce an large size components on this hot chamber molding process.